Earlier, I said that inheritance and polymorphism are overrated, and I can qualify that now by saying inheritance and polymorphism are overrated techniques for code reuse. You can achieve some fantastic designs with polymorphism, which requires some inheritance. You just need to be very careful with the inheritance part. Inheritance binds two classes together into a relationship that cannot be broken. And over the years, I found that inheritance can make software harder to change and harder to understand. Fortunately, there are a couple ways to reduce the amount of rigidity in inheritance. One way is to use abstract classes, and the other way is to use interfaces. Let's talk about abstract classes first. An abstract class is a class that you cannot instantiate because it is not fully implemented. The code on the screen is showing an abstract class to represent a window. So the scenario might be that we're building a UI toolkit and we need some base type to represent all types of windows on the screen. Dialog windows, transparent windows, modal windows. This type is abstract, I know, because it uses the abstract keyword in the type definition. And then the class goes on to define some members. Every window will have a title, every window will have a draw method, and both title and draw have an implementation. They are real working members. If you inherit from window, you don't need to do anything to those members. They are all ready to go. Although you can override either the property or the method because they're both virtual. And you could, for example, make the window draw itself using a different piece of code. But then there is the open method, which is marked abstract, meaning this method has no implementation. It ends with a semicolon and there is no body defined. To instantiate any kind of window, you will need to derive from this window class and provide an implementation for the open method. If you don't provide an implementation, you'll be building another abstract class that you cannot instantiate. But a class that derives from window and provides a definition for open, that will be what we call a concrete type. It's something that I can instantiate. So there's concrete types and abstract types. You can only instantiate concrete types. If you cannot instantiate an abstract type, why is it useful? It's useful because of polymorphism, because I can declare a variable of type window and use that variable to point to any kind of concrete window that derives from this abstract type. I can interact with any of those windows. I can set the title, I can tell them to draw, I can call open. Those three members are guaranteed to be there if I have a real window object. It must have been created from a concrete derived type. But when I wrote this window class, I didn't know how open needs to behave. That's why it's left as an abstract method. I just know there are other pieces of code in the application that need to work with these windows, and they must be able to invoke an open method to get those windows on the screen. And again, this goes back to the topic of complexity. Somewhere in the code, I could be working with window variables, and those window variables are useful because this window type will define everything I need. I don't need to know the specific derived type of window that I'm working with. I don't need to know how it was implemented or if there are 2 types of windows or 20 types of windows. I just have code that works with windows, and that's simpler and reduces complexity. Now let's use an example with our gradebook. Imagine now that the change requests for gradebook functionality are coming fast and furious. The business is discovering all sorts of different uses for a gradebook, different ways to compute statistics, different ways to store the grades. People want grades in a database or in an XML file. They want report cards, they want dashboards, and the implementation of gradebook.cs is starting to feel a little bit strained. It's not fulfilling all the needs of these different types of gradebooks. In fact, I might even take a step back and say there's a more general case of we need to track some grades, which is something a gradebook does, but we're going to add all these other classes that also track grades. And if that's the case, I might come in to the project and create a more pure type, a type that defines the things that I need to do without defining the implementation details. So an abstract class, let's call it grade tracker. In this grade tracker, I want it to be a public class, but I also want it to be an abstract class because ultimately I want gradebooks and throwaway gradebooks. I want them all to ultimately inherit from grade tracker. But when I'm building the grade tracker, I only want to focus on the general capabilities of what these different types of trackers can do. And I have a pretty good idea of what they need to do just based on the program that I've written so far. I know, for instance, that I will need the ability to add a new grade to a grade tracker. But what I don't know is exactly how that grade is going to be stored. Is it going to be in a list? Is it going to go into a file? Is it going to go into a database? I'm going to leave those implementation details to a derived class. So I will mark this method as abstract also. It has no implementation details. And I want to look at the public implementation details for gradebook. and give a grade tracker all these capabilities, but without the details. So for example, let's give all grade trackers the ability to compute statistics. We're just not going to provide implementation details there. Now this method will no longer be virtual. Virtual methods need an implementation, but this method can be abstract and implemented in a derived class. Back in the gradebook, I will also need to do this with write grades. So let me copy that method, the start of that method, paste it here. And this method will also be abstract. And I do need to bring in the system.io namespace for text writer. So control period and select system.io. And then back in the gradebook, I already have add grade as an abstract member. And now this name property and the name changed event and the logic to track changes and detect changes and manage this field. Let's say that this is something that will not change throughout all the different grade trackers. So what I'm going to do is actually cut this code out of the gradebook and add it to the grade tracker, because as an abstract class, this class is allowed to have some implementation details. So here is a real property that can be used, a name property, and a name changed event, and a private string underscore name. I might want to change this to protected only if I wanted derived classes to directly access underscore name. That's a decision I have to make, but in this case, I'll make it protected. And ultimately, the entire purpose of grade tracker is so that I can work with variables of type grade tracker in a place like my program and not worry about the specific type of grade tracker that I'm actually operating against, just like we did with gradebook and throwaway gradebook. But now we're introducing a new type, a type that it even has fewer implementation details in it. And ultimately, what I would like to do is work with a grade tracker here. Now currently create gradebook returns a type that does not derive from grade tracker. I will need to set up gradebook so that it inherits from grade tracker. But before I go over there, let me take this type name, and I want all these methods like write results and create gradebook. I want them to take parameters of type grade tracker. And in the case of create, return something that is a grade tracker so that I'm working with this low-level type throughout my program. And I think I've made all the changes there. So let's come back to gradebook.cs. And now instead of implicitly, or in this case, explicitly inheriting from object, let's have this inherit from grade tracker. And there's just a couple other things that I need to change. You can see I currently have an error. And if I hover over the red squiggly, Visual Studio tells me that gradebook does not implement the abstract member write grades or compute statistics or add grade. And the reason is this. When I implement compute statistics in gradebook, if I want this method to provide an implementation for an abstract method that is in my base class, then I can no longer use the virtual keyword. Instead, I have to use the override keyword. So an abstract method is implicitly a virtual method. Therefore, compute statistics is a virtual method in my base class. And I'm not trying to define a new virtual method. I'm trying to override that existing method. I'm also going to have to come to write grades and use the override keyword here. And with add grade, all of these were abstract methods in my base class. Therefore, they're virtual and I need to override them. And now I should be able to press Shift-Control-B to do a build. And my build is successful. Let me press Control-F5 to run the program. And I can still see that the results are the same and the results are correct. And the lowest grade is an 89.5. This is all good. But now inside of my application, I'm working with this abstract type grade tracker. And I no longer care when I call compute statistics or even add grade or write grades, what the implementation details are inside of here. And just so you can see the error, if I try to instantiate a new instance of grade tracker, that will give me an error. I cannot create an instance of an abstract class. So although I can work with grade tracker throughout this program, when I actually instantiate an object, it needs to be a concrete type. So it needs to be a gradebook or a throwaway gradebook.